So who wants to be a Bitcoin millionaire? So, it's been quite a ride, don't you think? It's been quite a ride, okay? So let's get started. We have a lot to cover in 45 minutes, so I'm going to skim through some slides, but I will share with you the slides later on so that you can study it yourself. So what we are looking at here is, this is my background here. Gentleman Sangam introduced me. So I work at Apple. I'm an avid data scientist. I have a startup in the Bay Area called Data Inquest. We do training and consulting in data science and artificial intelligence, and do a lot of corporate events. So as we have seen, the history of opportunity, we have been hunter, growers, warriors, craftsmen, explorers, merchants, mechanizers, industrialists, oil drillers, corporate executives, financiers, and startup founders. So last 10 years, 10 to 15 years has been a day of startup founders, right? So you saw a nice communication device released yesterday called iPhone 10. You saw a lot of new features in there, right? A lot of them were from the startups that Apple acquired, right? So that's the revolution that we are looking at of all the unicorns. So this site is familiar these days. If you are following Bitcoins, this is a mining rig, okay? Bitcoin mining rig, which is very common sight these days if you're following Bitcoins. And that's the center point of discussion today we are going to have, okay? So who is Satoshi Nakamoto? Satoshi Nakamoto coined the term bit and coin in 2008, just a fortnight after the historic meltdown of Wall Street, okay? So still people don't know who is Satoshi Nakamoto. There are a lot of speculation stories about that, but nobody knows who is Satoshi Nakamoto. So if you look at some of the statistics of blockchain today, almost $1 billion of investment by venture capitalists in blockchain development, 740 plus cryptocurrencies in the world today, 60 million average spend per day. Now it has gone all the way up to $1.5 billion. 400 million expected spend by banks, 25% savings of bank operational cost. So you see the statistics has been daunting these days, and it's making waves. Just yesterday, Bitcoin went up $400. Chicago's Mercantile Exchange has coined to approve Bitcoin as futures. And that's going to, once the regulation approves it, it's going to stabilize the price, and you're going to see a big increase in number of customers, right? So just the biggest exchange, Bitmain, saw 100,000 customers just yesterday, since the CME announced that, okay? So the age of data economy or data handling capabilities will define your future, okay? So that's the theme of today. So how do we define blockchain, right? So at its most basic, blockchain is a vast global distributed ledger or database running on millions of devices, open to anyone, where not just information, but anything of value, money, titles, deed, music, art, scientific discoveries, intellectual property of any transaction you can think about, it can be moved, stored securely and privately on the blockchain. Trust is established not by powerful intermediaries like banks, but governments and technology companies, but through a mass collaboration and clever code. So that's the definition of blockchain. And blockchain ensures integrity and trust between strangers. They make it difficult to cheat, right? So that's the HBR's definition of an article, Bitcoin and Blockchain of May 2016. So if you look at 2017 events, this is a heat map of events that are happening in the world where blockchain events are happening, including here. And you see the biggest block is in Europe, followed by New York City area, and then maybe San Francisco, and you see smaller blocks in Hong Kong area, in Singapore area, in Australia, and in Japan, right? So just earlier this year, when I started training in blockchain, sometime in May of this year, the Bitcoin price was around $1,800 at that time. So it has gone all the way up to $7,400 or more today. So this was the headline news of just before I came to this talk. Coinbase, the largest US Bitcoin exchange, just added 100,000 customers. Blockchain explosive growth pushes job skill demand to #2 spot. That's a Computer World article just published yesterday. Amazon registers domain names. 3 domain names have been registered: AmazonCryptocurrency.com, AmazonCryptocurrencies.com, and AmazonEthereum.com. Chicago Mercantile Exchange is launching Bitcoin futures, and we are seeing a lot more news out there. $1 trillion industry being bought onto blockchain. Your next passport could be of a blockchain. IBM is using blockchain to speed up, simplify cross-border payment, and Sony wants to digitize education records through blockchain. So you see a lot of headlines. I'm going to share these slides with you. You can go through it again later on. So you see Japan has Jcoin, Australia has approved Bitcoin transactions and other blockchain-based ICOs, and they have stated that there is no regulation on these. So has Singapore. Okay? So there are a lot more news items. I'm not going to go through it. We have a very limited time. But what I wanted to just make a point here is it's not a myth. It's not a fad. It's not something, a hype that's going to go away. Okay? So that brings us to the hype cycle. So if you look at the blockchain, the Gartner hype cycle just published just 2 weeks back says blockchain is at the peak of inflated expectation. That's where blockchain is. You see it on the right-hand side, bottom of the peak of inflated expectation. So that's where blockchain is today, and that's the hype, usually. That's where the hype is. And you see other technologies out there, like deep learning. We are here. We have been, almost every other talk is about deep learning here, right? That's another hype machine, right? So you're going to see that happen a lot. This is the current Bitcoin price right now, $1,700, $7,100, okay? With a market cap of 0.118, almost $0.12 trillion, okay? So that's a market cap of Bitcoin. This is Ethereum, market cap of $29 billion. The price is $302, 57 cents. So this is the current price as it was just an hour before, and it is keeping at that level. So if you look at the bubble territory, right? So you start with takeoff, first sell-off. You started media attention, enthusiasm, greed, delusion, new paradigm, denial, return to normal, fear, capitulation, and return to median. Okay, so Bitcoin is essentially going through a classic bubble territory, right? It's a classic bubble territory. That's what we are looking at here. Okay, so you start with still phase, awareness phase, mania phase. That's where we are in right now, and then blow off phase. Okay, all the bubbles go through that like this, but we don't know what the length of it, right? So if you look at the cryptocurrency to crypto economics, we start with billions in currency, billions of dollars, transfers, payments, trips, crowdfunding, followed by millions in packed services like naming, identity, ownership, membership, voting, hundreds of thousands of smart contracts, thousands of decentralized autonomous organizations. So that's where cryptocurrency 3.0 is going to go. So started 2014. So we are talking about mobility today. We are talking about big data. We are talking about deep learning, AI, machine learning. We are talking about fog computing, right? Cloud is old already. Everybody's talking about fog and edge computing, right? So before 2005, it was all about big banks, big institutions. You go there to get services, and monopolies, oligopolies were very common before 2005. Today, we have control over our smartphones and computers. We are able to order all the services. All the middlemen are out. You don't have to go through big red tape to get your services. Versus 2025, when everything will be connected, all your sensors will connect all the devices that we use on a daily basis with the cloud and on the edge. And that's when you will need internet form in blockchain era. Okay, that's when you need internet form in blockchain era. So what is a blockchain? It's a block, decentralized nodes, cryptography, and a protocol. Okay, and that gives us to a Turing complete programming language. Okay, so that's a blockchain framework today. So we will go through each of the components in details. These are the top 5 currencies today. Bitcoin is at $0.12 trillion, right? One Bitcoin is around $7,100. Ethereum is 28 billion market cap. Ripple is 7 billion market cap. Litecoin is another 3 billion, and Monero, which is one of the classic ones, is 1.3 billion. So how has money transformed? So we start with barter systems, then we went into gold coins, then fiat money, followed by online banking, digital representation, to credit cards, digital money, and bitcoins. Okay, so that's the sixth generation of money that we are looking at, totally decentralized digital economy. So how do we define blockchain? I already went through a HBR definition. Defining blockchain is simply a data structure where each block is linked to another block. The blocks are linked to each other in the time-stamped chronological order. Every new record is validated across distributed network before it is stored in a block. And each block is identified by its cryptographic signature, right? To extract data of first ever created block, you have to traverse through the last created block to the first block. That requires a lot of energy. So right now, one Bitcoin transaction requires energy equivalent to your home's energy usage for the whole year. One Bitcoin transaction, right? So how long it is sustainable, right? So you look at Envion, it's a startup. They are building cold storage containers with at least 12,000 GPUs inside. The 16-feet containers, you can move it to the solar or wind or hydroelectric plant and install it right there and start mining your coins. So that's how innovative people are becoming to try to see how you can mine the coins of the last bit that's left. So how trading happens using current system? Trade is recorded in a bookkeeping, offline ledger. Bookkeeping is isolated, close to the public. From this reason, we use trusted third parties or middlemen we trust to facilitate and approve our transactions. So you go through institutions, you go through your Barbas, or you go through the exchange agencies, or companies like Fiserv who go through the transaction for you, right, and approve it. So what's the problem with the current system? It's the banks and other third party take fees for transferring money. Mediating cost increases transaction cost. System is opaque and lacks transparency and fairness, and central authorities' control can overuse power and create money as per their own will, right? So that's the problem with current system. So what is the possible solution? We need a system. Cost of transaction is nil or minimal. Speed of transaction is faster. Record of transaction is transparent, visible to all for better security. Currency creation is not in control of any authority. So that's why Bitcoin price has so much volatility, because the number of Bitcoins are pegged at 21 million. There won't be more than 21 million Bitcoins. That's why you see so many forks these days. Bitcoin Cash, Bitcoin Gold. Every other month we are seeing a fork, right? Because those forks are changing the rules and they are increasing the number of Bitcoins in the market, right? So what is distributed system attempts to solve a problem? So we have a centralized network today, decentralized network, or distributed network. So these are the representation of three networks that we have learned in high school. Distributed system enables a network of computers to maintain a collective bookkeeping via the internet. This is open, is not in control of one party. It's available in one ledger, which is fully distributed across the network, right? So what does that mean? A distributed system is where two or more nodes work with each other in a coordinated fashion in order to achieve common outcome. Okay? So let me show you a demo of a blockchain. Okay? So let me show you a demo here. So this is a SHA-256 hash. If you took a network security 101, or if you took a cryptography 101 course, you know what is a hash. Well, you know what is 256-bit hash. So you see here, this is a 256-bit hash. So if I change the data, the hash is changing, okay? So let's go to a block now, okay? So I'm at the block, and this is block number 1. I have a nonce. Nonce is a problem, right? It's a problem. I will talk about nonce later on. And this is a hash for that. So now let's say I want to mine this coin, mine this transaction. So I'm going to change this, and this turned pink and red, okay? That means that this particular transaction is incomplete right now, right? There's a mismatch. So I'm going to click on mine, and it's going to go through all the hash possible, and it's going to turn green when the mining is done. Then I go into blockchain. These are the chain of transactions. These are each block in a series, right? Each block is in a series. So if I'm going to change this one, all of them after this will turn red. So I have to mine each of them again to get to my result if I want to go to number 5. If I change this one, even 1 will go down, right? So I have to press mine in each of them to get to where I want to go is transaction number 5, or block number 5. And that's the challenge usually in a blockchain. And that's why blockchain becomes so secured, because the amount of energy needed, amount of resources needed to go to number 5 and press mine on each of these transactions is enormous. You need a lot of resources to go to that point, okay? So that's a blockchain. Now, what is a distributed ledger, distributed blockchain? So you have peer A, peer B, peer C, and so on, and each of them are connected to each other and within and across, okay? So if I'm going to change something here, all of them will turn red. They all are connected to each other, okay? So I have to press mine on each of these peers to get to my transaction number 5, okay? And what is a token? Token is all these transactions you're making with other people. You have to go through, let's say I change the transaction amount and all of them turn red. So I have to mine through each of them to get the transaction to go through or modify a transaction that happened a couple of days back, okay? And this is just a demonstration of how a blockchain works, okay? All right, so let's go back to our slides now. So what is a node? A node can be defined as an individual processing unit in a distributed system. So the demo I showed you, it's running on a Node.js server on my computer, okay? All nodes are capable of sending and receiving messages to and from each other. A node is a distributed system. Initiating a transaction in a network, let's say James wants to transfer money to his friend Kevin. Now, since there is no central authority in the system, there can be certain questions that might cross your mind. Right? How to verify whether transaction is initiated, to whom to it sent. How is the transaction faster than the present system? Who validates transactions since there is no central authority, right? So I can go to this website called blockchain.info, and I can look at all the transactions of Ethereum, Litecoin, Bitcoin on this hub. Okay, this looks better on the Chrome than Safari, so I'm going to go to Chrome here. So this one, you look at all the different wallets here. If you have a wallet, you'll show up here. I can look at the data, and it shows all the charts and all the transactions on blockchain.info. It shows the market price of Bitcoin right now, average block size, the transactions per day, mempool size. We'll be going through each of these definitions in a while here. The currency stats, Bitcoin circulation, the number of Bitcoins in the market today. It'll go through the market price, right? The trend in market price, market capitalization, right? It will show you that. And USD exchange trade volumes, okay? So you can go through that, and it's on a tier these days, okay? So that's the blockchain.info. I want you to go through that and understand how the transactions happen, and that's a centralized location. So initiate a transaction, James uses two pieces of information, a private key and a public key. Private key is like your credit card or your password, to your bank account, right? So you don't want to give your private key to anybody. You open a wallet, you create a private key, the wallet gives you a public key, and those two information will let you do a transaction, right? So Coinbase just opened a wallet a couple of months back that can do even pennies transactions. So you can buy Bitcoins for so few pennies also if you want, right? So Coinbase is becoming a very powerful authority in this area, right? So Kevin has to pay $500, sign and encrypt. Kevin has a private key, and James want to pay $500. He wants to pay $500 to James, and that's the public key. So he'll give his public key to Kevin, and the transaction will happen. So public key cryptography. So you have some text, a symmetric algorithm, private public key, and that will give you the hash. One key is purposely kept private, the other is provided to other party. If by chance, if you lose your private key, you lose your money, right? So that's a very important information you want to keep safe, right? Bitcoin address wallet. This is how the Bitcoin address wallet looks like. You have your, this person has 2.08454.166 Bitcoins, and these different transactions that that person has done. An identifier of 2635 alphanumeric character beginning with number 1 or 3. Bitcoin wallet is basically a Bitcoin equivalent of a bank account. Okay. This is sending a transaction, Kevin to James, 5 Bitcoins. This is a digital signature that's created. So we'll go through a term called Merkle tree. So that's coming up. How transaction propagates in distributed network. In a distributed architecture, transaction is transmitted peer-to-peer. Transmission of transaction across networks takes around 1 to 2 seconds. And suppose A finds transaction, Kevin pays 5 coins to James. This is what happens, A to B to C, and then all the other nodes, right? And all of them have to have a consensus for that transaction to go through. This is faster and cost efficient. It's in middle run. Who are the miners? Miners are special nodes which hold copy of the ledger and verifies the transactions happening in the network. Using state-of-the-art cryptographic algorithm, miners validate the transaction across the network. The originator of the transaction possesses the funds being transferred. The originator of the transaction has obtained the funds by one of the means commonly recognized as valid. Right? So in order for our digital monetary system to work, the miners must be able to confirm that. Okay? So that's and miners get incentivized by a small amount of Bitcoins. But what's going to happen by 2025, the Bitcoin will reach the maximum. If the way it's going, it will reach the 21 million. So then there won't be any incentive for miners at that time. So they have to find out a rule or some method to incentivize miners after it reaches 21 million. So James's wallet is a private key, public key. James gives 5 Bitcoins to Kevin. Digitally signed signature broadcast to the network. It goes to the distributed network. Digitally signed signature, James public key, and transaction message authenticated using James public key. Right? Distributed ledger. James, Kevin, Robert, Paul, you can think about a distributed ledger. This is how the ledger looks like, okay? Ordering of transactions. Since transactions are passed from node to node, there is no guarantee. Miners group the transaction in a block and then transfer it, okay? Lisa to Sandra, Mary to John, James to Kevin, all of that goes through the nodes and becomes a block. One block is 1 megabyte. A block cannot be more than a megabyte, okay? So if it's more than, if there are more transactions coming at a given time, more than a 1 megabyte, then it will go to a mempool, okay? So there's a whole debate about mempool size, and everybody wants to increase the mempool size, and the latest fork that happened in Bitcoin Gold increased the mempool size. So these are the number of blocks, block 145, 146, 147, 148, and then 149 is being created with all these transactions in it. So existing blockchain, new blocks, block proposed by Lisa or block proposed by Paul. Various miners are constructing the blocks. There could be several options to choose from. How does the network decide which block should be next in the chain? So there's a whole block puzzle. I'm not going to go into too much detail, but that's the high-level cryptography that goes through and the rules that goes through which block gets picked. But in a very simple layman term, I can tell you that the block with more integrity, block with more legitimate transactions picked up first, right? So if some of the miners think that this particular block has some fraudulent transactions, that block will keep wandering around in the ether space until it's rejected. Okay, so easier ones get picked up first. Okay. So security properties of hash functions are they're collision-free, they're hiding, and they are puzzle-friendly. Okay, so that's the hash function security properties. That's why it's used in blockchain networks. And what are the miners' rewards? What do they do to get this? Right? Miners tries to find the key to complex puzzles as per the algorithm. Like I showed you, I pressed the mine button. It was a very small blockchain, so it was able to do it in a few seconds. But in reality, it takes around, right now, one Bitcoin transaction takes anywhere around 15 to 20 minutes to process. Sometimes it's even longer. So miner tries to find the key to a complex puzzle, the search for this key in random, and so miner needs to invest huge computational power and electricity. So the photograph I showed you, and I'm going to show you a video towards the end, it shows how much power is needed and electricity is needed. So that's why most of the mining rigs have moved out of the United States because of the cost of mining. Okay? So this is a mining rig. I have set up in my university where I teach, and let's see, I had it working. Okay, here it is. So this is the mining setup that I have for my rig here. This is the mining that's happening as we speak right now. Okay, so this is a kind of very small mining operation that's running for our students in the university I teach. Okay, so you see that it's quite expensive to do that. Okay, so let's go back to the slides here. Okay. Okay, let's close it. Okay. All right. So some humor to go with it, right? It's becoming too boring. Okay. So miner rewards, so that's the miner's reward. The miners invest in computational power and electricity. The miners are repeatedly guessing new keys until first key is found that matches the puzzle. The miner who finds this key publishes the block to the network, and other miners stop creating their blocks and will take published block and validate it. Okay? So that's the miner's job. And the reward is electricity. That's a finite electricity. So they are saying that in Netherlands, a lot of these mining rigs, they don't use heaters to heat their water. They just pass their water through the rigs, and they use it for shower. So that's the electricity, computational work, right? Computational work, and then you have monetary rewards. Okay, so that's your that's the reward for miners. Okay, and currency generation as a result of incentive to miners, new bitcoins are generated, newly created bitcoins are sent to the miner's address. Right? So as an incentive, new bitcoins are created. Okay? So what is proof of work? Proof of work is very, very important concept in bitcoins. Okay? Existing blockchain, you have transaction block, you have Bitcoin miners, you have a challenge, you have a proof, and cryptographic hash function, that's a proof of work. Right? And proof of work is one of the most important part of the blockchain. What is consensus algorithm? Consensus. There's a consensus conference that happens every year in February or March timeframe, somewhere in the United States or some other part of the world. The consensus algorithms are central to functioning of any blockchain. So if you're planning your own private blockchain, you need to have a consensus algorithm, right? There's a contradiction among nodes about the blocks in the network, such as contradiction is resolved by the consensus rules. So if there is a contradiction between nodes, between miner pools, if there are contradictions, they go back to the book. They go back to the consensus rule, and they go through that, and that gives you them the direction of how to resolve their conflict. Consensus is a task of getting all processes in the group to agree on some specific values, and value based on the votes of each processes. Okay, so that's a consensus. With consensus algorithm, we need to get unanimous agreement. And then there are several branches, and we talked about branches. I'm not going to go into too much detail of which branch gets selected. So I'm going to skip this part of the discussion here. So essentially, in a very short form, I can say that there are many, many branches, and the tie gets broken. If there's a tie between branches, the tie gets broken when someone solves the next block, because it's very rare for this situation to happen multiple times in a row. Okay, and the longest chains get most attention in the miners. Okay, because they get the most incentive for that. Right? Okay. So what if a miner tries to cheat with the system? Right? There's a 51% rule. 51% of miners, if they collude, then there is a chance that there can be fraud in blockchain, but that's very, very rare. So there's a reward for solving a block. There are chances the miner might give wrong solution to the block. After creating a block, miners has to publish the block with proof of work of the network. Other miners validate the block. If the proof of work provides is wrong, the block is considered to be valid, as a result of which miners end up exhausting the resources without getting any reward. So that's the key. The consensus mechanism doesn't allow anyone to cheat with the system. Okay, that's the strong point. Okay. So what if someone tries to hack the system? Okay. Once a block is solved, the cryptographic hash output becomes identifier of that block. If someone tries to alter any transaction in any block, the hash of the block changes. And that's what I showed you in the demonstration, right? The hash of the block changes. Consequently, hash of every block changes, and nodes will not arrive at the consensus, hence the fraud can easily be detected. Okay? Because each of these nodes, because one person can be a malpractitioner, but other nodes are honest, they will detect it right away. There's no way to alter the system because it requires a lot of energy and resources. Is it possible for someone with an extremely fast computer to outpace every other one? It's highly unlikely that someone can do that even with thousands of computers. Okay, so transactions are protected by race, right? It could require more than 50% of total computational power of the entire system to have a probability of solving a 50% of block faster than someone else. So that's the rule, right? To sum up, how does the whole blockchain and transaction system work? Is encrypted by asymmetric cryptography, propagates peer-to-peer, are stored in public ledger, is authenticated by the miners, is secured by consensus algorithm. All these concepts constitute a blockchain technology. Okay, so that's how you sum up all of the blockchain, right? So what are the benefits? Settlements happen in real time, cost savings. A lot of banks, if you go to chain.com. Today, or you go to a lot of consensus-based websites or the sponsors, you will see that most of the banks are trying to change the internal bank transfer systems, especially for international wire transfers, to a private blockchain. Most of them are doing that because it's a big cost saving for them. Security and resilience, immutability, right? We have talked about that, and user pseudonymity, right? So the users are not identified. That's why most of the attacks, the ransomware attacks that happen, they ask for bitcoins because there's a pseudonymity of the users. So the use of mathematics to create a secure ledger, this enables transactions without the need for third parties, access to shared single source of truth, right? That's the blockchain, okay? There are many blockchain project ecosystems like currencies we have been talking about. Then there's developer tools, right? Smart contract tools, Oracle ICE, legal security, interoperability. We have privacy, right? We have DAX, VPNs, identity, the sovereignty technology. FinTech is big, trading, insurance, lending, value exchange, shared data, authenticity, ticketing, other stacking pools, and other project ecosystems in blockchain. So what are the implications? Decentralization and distribution, political and economic balances, power dynamics, alternative economies, middlemen, speculation and investment, cryptocurrencies versus fiat versus credit, and ethical computation, right? So these are the implications. So what is a programmable money? Okay, cryptocurrency is a programmable money. Okay, so function start equal hello world, and it gives you an ID, the hash. Each unit individually identifiable, programmable. Users can assign properties to each unit, and users can program a unit to represent Eurocent or a share in company. Okay. An example of how cryptocurrency can be programmed. Alice buys a car online from Bob. The payment will only be executed after a car has been delivered. So I'm working on an ICO with my colleagues on a green token. So a green token is going to be for people who buy electric cars. So if you buy electric cars, we will give you a set of tokens. And more you drive your electric car, you get more and more tokens, right? And so that's how the whole ICO world is forming these days, right? Every other person you know, they are forming an ICO. China already banned ICOs, okay? So that's the programmable currency. That's a cryptocurrency that can be programmed, and this is what it's explaining, okay? So Bitcoin is first implementation of blockchain. You have Litecoins, you have Ethereum, and so on, other ones. A blockchain beyond Bitcoin, monetary aspect is just a tip of an iceberg. Blockchain is groundbreaking technology for which money is merely one of the possible applications. Okay? So you have industry flows, asset management, smart contracts, identity management. So where Microsoft and IBM and others are going is blockchain as service. They're going to have a cloud instance or an edge instance that will create blockchain on demand, right? And that's where the real business is beyond Bitcoins. Okay? So what is a blockchain, right? It's a magic computer that anyone can upload programs to and leave the program to self-execute, where current and all previous states of every program are always publicly visible, which carries a very strong crypto-economically secure guarantee that programs running on the chain will continue to execute in exactly the way that blockchain protocol specifies. So he used exact words at the Disrupt conference, the TechCrunch Disrupt conference just a month back, right? So as I said, it was invented by Satoshi Nakamoto. Later with time, it became a single word blockchain. from 2014 onwards, blockchain 2.0, that's what we know today. And this is a flow diagram. We went through that. So let me show you a package in R that can do a lot of magic for you. Okay? So there is a package in R called R Bitcoin. Okay? So let's say you have a wallet. Okay? You have your own wallet, or you have your friend's wallet. You want to do analytics on it, or you want to just look at the market trends and how many transactions are happening right now on Ethereum, Litecoin, Bitcoin, Monero. So you can just use our Bitcoin, and I'll show you some examples here. So I'm using the market API called Kraken. So I'm going to start with the library R Bitcoin, and then I'm going to start to see if I can. The first command, I believe, doesn't work. We can try it. So this shows from Kraken, that's the exchange. Let me make it bigger for everybody to see. Okay, so this is what is showing here is market base code, timestamp, and last transaction. So it's showing you all that information live, right? Ask and bid. So somebody's asking and bidding for it. Then I'm going to look at the latest trades. Okay, so I'm going to look at the latest trades here. Okay, and I'm going to plot the trades here. Okay, so same thing. In Python, you have a package called PyCoin. You can do the same in that also. And this is a trend of the latest trades. Okay, that happened just recently. I can look at a wallet. This is one of the wallet hashes here, and I can look at the hash and see what this wallet is all about. Okay, and I'm going to start as the seed and a genesis and a single address. So these are all the hashes that are provided when you complete a transaction and create a wallet, and then I'm going to look at the whole blockchain network created here on my Quartz. Okay. So this is going to create that diagram for me. So you see, these are all the transactions that have happened with this wallet and the different networks that have approved it, and it shows the whole, all the transactions and the amount, and each of these nodes and the branches shows how that transaction got approved. That's in the red here. Okay, so that's the blockchain, our Bitcoin. You can download the documentation of our Bitcoins, and they have a lot of features in that package that talks about that. Okay, so just to wrap it up here, we are out of time. 3 more minutes. Yeah, okay, 1 more minute. 5 more minutes. Okay, so the major innovation in blockchain has been blockchain was first implementation of blockchain. Blockchain was the second innovation, essentially realization that the underlying technology used by Bitcoin could be separated. The third was the smart contract embodied in blockchain 2.0. The fourth critical innovation is proof of stake. Is the current generation is secured of proof of work. That's the Ethereum that we know today. It's a proof of stake. So reasons why blockchain is disruptive technology today is secure. That we are saying that this is the internet of 2020. Okay. So that's the secure worldwide adoption, automated operation, open distributed architecture, flexible. So as the trust in governments and politics and banks are waning these days, you are going to see Bitcoin as a resilient currency that's going to survive. It has gone through a lot of ups and downs, like you know Mt. Gox or the Silk Route, right? All of them got closed in 2013, 2012 timeframe, but you see that the bull market has started all over again. Okay, so blockchain versus traditional database. You have operations. Only insert operation in blockchain is write once, read many times. Traditional database is CRUD operation. Replication, consensus, invariance. So blockchain can be used not only in currency transactions, but you can use it as a database. It's a distributed ledger. Do not require such a chain, do not require proof of work. Offer theoretical better scaling options versus blockchain. A sequence of blocks require consensus algorithm, not so easily scalable. So there are many use cases out there for supply chain. So I helped a company recently. They are trying to authenticate luxury goods, and they are applying blockchain for that. Another company I helped is for automotive parts. They are creating blockchain of automotive parts. All this is happening mainly in China. So they are trying to build a blockchain of components in the car. Okay, so you can't have a third-party part which is not legitimate. The car won't run, right? That happening in the phone business also. A lot of companies are trying to do that. There are also systems that are around the green economy. I was telling you about the green coin. Okay, so I will share with you the slides. There's a lot more we can talk here, but we are out of time. So I'll take some questions from the audience, and I represent Data Inquest. So you can go to datainquest.com. We offer training in blockchain technology. We have a boot camp coming up on 9th of December on blockchain. And 2nd December is a boot camp on deep learning. So we have 80% hands-on workshops. I see a lot of familiar faces. They've already attended our training. So you're most welcome. Go to datainquest.com. So if you liked what you showed, this is just a small bit of what we cover. Okay. So any questions?
Thanks for the primer on blockchains. You did a good job explaining that upper level. How does data science get applied to blockchain technologies now that you have this transparent database? In what ways is data science used against blockchain?
Right. So there's a very good article from MIT Press on this, just published last week. So what they are talking about is as we are seeing real-time transactions, as we are seeing a lot of private blockchains, right? Especially in supply chain or in fintech. So you're going to see a lot of private blockchains being formed using Ethereum, right? So you need to learn Solidity, which is a Turing language out there that can program those contracts, right? So and once these, so I showed you the R Bitcoin, there's a PiCoin, there's a Chain.com, and then there's a whole cloud infrastructure you can build to optimize your trading, right? There are a lot of opportunities. Like I showed you, the Computer World published an article last week saying that the skill set required for blockchain is number 2 spot, right? After info security. So there are a lot of jobs in infosec data science in this area also. Like if you understand cryptology, if you understand the packages, if you understand Solidity, you can help build startups and the ICOs that are happening these days. You can help that. The other one I would say is reporting, analysis reporting, building predictive models. That's going to be out there. Because every transaction you see today, we are going to an institution because we don't trust the third party. If blockchain can be used efficiently, all those transactions can be decentralized. So that's where data scientists can contribute a lot in finding the best way a transaction can be implemented from a population that you look at, right? So I mean, I think it's going to take a year. I mean, you're going to see that take off. Right? Once Bitcoin gets regulated, that will happen soon because the Bitcoin futures are already approved, I believe, by Mercantile Exchange. So that's the money 2.0.